Okay, so in this video, let me show you for the process XC, they tell us that the work done is 1250, but we ought to be able to figure that out, right? For XC, all we have to do is find the area here, right? Find this area. It'll be slightly less than the area. There we go, right? We want to find that area, and that area is going to be the integral of, from V, we'll call this V2, and we'll call that V. Notice these are times 10 to the minus third. This is V1, right? So the definite integral of P dV, right? So now we got to find a formula for the pressure in terms of the volume, right? So we can do that, okay? I'm not necessarily answering this question. Okay, so let's figure that out. So this is, I'm going to call this P naught V naught, right? And then this will just be P and V, right? So we know that P naught V naught to the 5/3 is equal to P V to the 5/3, right? Okay. So therefore, my pressure at any given time is P naught V naught to the 5/3, right? Times whatever volume you're at to the negative 5/3. All I've done is I've divided by V to the 5/3, right? V to the negative 5/3 is the same as 1 over V to the 5/3, right? Okay, but I'm just writing it like that because we want to apply a simple integration rule, okay? So this becomes the definite integral of P naught V naught. Now these are just constants, remember? They're just given to us, right? 8 and 2 are our initial, right? Okay, and then we're going to go, the thing that's actually varies with volume is this guy, right? So then it's going to be V to the negative 5/3, and then we're going to, that's dV, right? Okay. Well, we could just, this is just a simple polynomial or a simple power rule, right? Okay. So if we add 1 to that and invert it, we get negative 3/2, right? Okay, and then it's going to be this constant, right? P naught V naught to the 5/3, right? And then this, we're going to add 1 to that, right? So that's going to be V to the minus 2/3. And then we're going to evaluate that from, what are we? We're evaluating it from 6E minus 3 to 2E minus 3. So what does that look like? Okay, so that's minus 3/2. And then it's going to be the initial pressure, which is 8 times 10 to the 5th, right? 85. And then it's going to be 2E minus 3. That's raised to the 5/3, right? So those are our constants. This is constant, right? And then we're going to have, we're going to do this, right? It's going to be 6E minus 3 raised to the minus 2/3 minus 2E minus 3 raised to the minus 2/3. We can do it! It's very complicated, but we can do it. All right, so here we go. So the opposite of 3 divided by 2 times 8E5 times 2E minus 3 raised to the 5 divided by 3, hit the right arrow, times parentheses. I don't need the times, but I'm just, and then I'm going to go 6E minus 3 raised to the negative 2 divided by 3, hit the right arrow, minus 2E minus 3. This is very complicated. Not really, though. You just have to be able to type stuff in. Negative 2 divided by 3. Hit the right arrow. Boy, I hope this works. I got it, baby. Okay, so that integral, if you work this out, is 1246.2 joules, which is where I got this. Okay, they will tell you stuff like this just because they don't expect you to know calculus. But you know what? I just wanted to show you that because you learned all this calculus and it just applies to this. So let's I don't know.